This is our second video out of 1.5 volumes of right pyramids and cones. We did a quick review of our 3D prism shapes and saw that the area of the base times the height gave us the volume of those shapes. Well, it turns out for right pyramids, we have exactly a third of that. So we still do the area of the base times the height, but we multiply by a third. That's true of pyramids, as well as for cones. You can think of a cone as a third of the volume of a cylinder of the same radius and height. So our first question over here says we've got a square pyramid and we want to know its volume to the nearest cubic inch. And we're given these dimensions, that its base is a square 10 by 10 and its slant height is 8 inches. Notice our formula doesn't actually want slant height. The area of the base is easy enough. Area of the base is going to be 10 times 10 inches. But the height is needed, not the slant height. So we got to go over here again to our little Pythagoras relationship and say, okay, well, the slant height was 8. The base was 10 all the way across, but if we draw a right triangle that includes the height in it, we're only going from the middle of the base. So 5 squared plus h squared equals 8 squared, or in other words, 8 squared minus 5 squared equals 8 squared, and I get an ugly answer of the square root of 39. I'm going to leave it like that for a second so that I don't round it too early. Now I can jump over to my formula and say, okay, volume of a square pyramid should be 1/3 10 times 10 for the area of the base, and then multiply by the height, the actual height of the pyramid, and crunching those numbers, I got 208 approximately cubic inches. And you can write cubic inches in words as they often do, or as inches cubed that way.